Hi, I'm Callie Stroscup. I am a site reliability engineer, and this is the Deploy in Public workshop. This is challenge number 8 in a 10 challenge workshop. So if you haven't started from number 1, I recommend going back and starting from there because each of the challenges build on one another. Today's challenge is pretty cool though because we are starting a new topic, Kubernetes. We're going to explore AWS's Managed Kubernetes Service, EKS, by creating a deployment that runs a pod with an NGINX server on it. And then we're going to create a temporary pod from within our cluster to access that NGINX homepage. It will be pretty cool. Oh, and did I mention all of this will be done within a private EKS cluster? If that sounds fun to you, I say keep watching and try the challenge. If it doesn't sound fun to you, that is okay. I feel a little bit like a nerd being so excited about all of this. Thanks for watching. And we are going to spend this week transitioning a little bit from using EC2 directly to using EC2 indirectly through EKS, which is Kubernetes. Well, which is Amazon's managed Kubernetes service. All right. And I think it'd be best at this point if we take our very long main.tf file and modularize it a little bit. So that way we can pick and choose which modules we'll use when we end up using switching over to EKS. All right. So the first thing that we can look at is we already did the VPC module. So you'll see that we have our main.tf, our outputs, and our variables. All right. And that is what each of our modules are going to have. We need to be careful, though, in how we do this to avoid circular dependencies. So let's first determine what modules we want to make. So we have a security group for private security, the ingress rules, the egress rule, and the private instances. So that essentially will be its own module for private EC2s. All right. We also here have an IAM role. And then we have two policy attachments to that role. And we have an instance profile. All right, which is using that role. So those are all related things. So I would think that we'd also have an IAM module. All right, so maybe let's take notes. So here we are going to have a private EC2 module. All right. And then here we could have maybe our IAM module, which would include all of this. Now we are going to have a load balancer module. So we have the security group for the load balancer, the ingress rule, the egress rule, the actual load balancer, an API target group, API attachment, a front end and front end attachment, and a listener. So that's going to be and then a listener rule. So that's going to be a lot of things in the ALB module. And you have to be careful because you can see that the load balancer refers to private instance IDs. And then you'll see in the private instance module that we refer to, well, first off, we refer to IAM. So, and we also refer to the load balancer. So if we just completely modularize this and we have load balancer with everything in it and then private instance with everything in it, we'll end up having a circular dependency. So we're going to have to be strategic about how we do that. A circular dependency is where the EC2 module depends on that load balancer security group, and then the load balancer depends on the private instances to be completed to get information. So because of that, they each depend on each other, so they'll keep circling and circling and circling. All right. Next, we have an ECR module, which will have our repositories in it. And then Here, it looks like we will have our database module, or maybe we'll call it our RDS. All right. And then finally, we are going to have our Bastion module, at least I think finally. All right, so we have a lot of modules to create. I think I am going to kind of start simple and then work my way up. So I don't think I'm going to tackle the private EC2 quite yet. I think the IAM seems to be pretty simple, or so we think. So let's start with that. So I'm going to have an IAM folder, and then the first thing I'm going to put in is a main.tf. Then I'm going to copy everything that goes into my IAM module. I'm going to cut it out and I'm going to paste it in here. So the reason why I start with the main is because it helps me identify what that needs to be in my variables.tf module. So you can see that we need a variable called app name and a description. And then this would be value of app name is fine and type string. All right. So now we know, and now that is no longer yelling at us. All right. So then we would just look through for anything else that is used from a different module or a variable. And I don't see anything. So this should be fine in terms of the things, the variables that we need. All right. So then if we go to the main here, we want to call that module. So module IAM. And then our source is going to be from the IAM. And then you'll see we have the red squiggling line because app name is not specified and we need to have it. So we can say app name is going to be equal to var.appname. And so there you have it. We have an IAM module. Now, what I would do here is every time you modularize your code or you change a big chunk of code, I would go ahead and rerun Terraform apply to see if any errors come up. And you could even potentially apply everything and then run your GitHub Actions and make sure that everything is still deployed properly. All right. So we will just at least do the first part, which is just do Terraform apply, but this is going to help catch some of the issues that maybe when we moved this code happened. So first we have a module that's not initialized yet because we just created one. So we're going to have Terraform init, and then we can Terraform apply. It is going to be mad because I'm not using -var -file equals secret.tf vars. All right. And so now we can let the errors kind of guide us. All right. So I'm seeing that we don't have a DB username and password, which we should. So I'm wondering if I got it wrong. Secret.tf var dash file. All right, I'm going to worry about that part later. But the part that actually is concerning to me is it's saying that on main.tf line 81, so right here, it's saying that we're referencing this instance profile, EC2 profile name, but that doesn't exist. The reason for that is because we moved that resource inside of our module. So we're going to need an output too. So we need to go to outputs, create a file outputs.tf, and then we'll make an output, and we can call this EC2 profile name. And the value is going to be, yes, that looks good. All right, so now we can go back to main, and then whenever we have that, now we just need to say module.iam.ec2 profile name. And then let's find the second, so 277. And then that is going to be module.iam.ac profile name. All right, so now that we have that, let's go ahead and do Terraform apply. And now you can see that it is just going to be happy with us and create everything. All right, so I am actually not going to create everything. I will say it would be good practice to go ahead and do it, but I already did a practice run through modularizing my play around with Terraform repo. So this is kind of me just running through it the second time. So I'm going to say that the Terraform apply here is enough, and I'm just going to do one deploy at the end of all of our modularization and, hope I didn't mess anything up. All right, next. So that is one module that is out of the way, which is exciting. All right, so we have this module. I'm going to go ahead and move this module up so that we have all modules moved up. I have providers here, but it's just passing in the region. So I think I'm going to delete the provider out of here and just keep the provider AWS at the top of this. And so that should be fine. And then I don't know let's see if the actual main needs region. So we're going to go with find region. It doesn't need region. So the reason I'm doing this is because if I have a provider in each module, then I'm going to have to pass in region as a variable to each module. So I would rather not do that. And if it works, yay me. All right. So then main, we don't need to send in region. Save that. Excuse me. All right, so that looks like that is going to work. Okay, so now we have a VPC and an IAM. All right, so I'm still going to not do my EC2 yet, and my load balancer, I think it's going to be another tricky one. So I'm going to try to work up to those by doing the harder ones first. All right, I'm going to get rid of that note. ECR module, that actually doesn't seem bad. So let's look at what this is doing. So this is creating an ECR repository for our front end and an ECR repository for our back end. So we don't need to have a module that does both. Instead, let's make a module that does the creation of an ECR repository, and then we can just pass in what the name of the module or repository should be. Okay? If that doesn't make sense, I hope it will in a moment. So we're going to create an ECR folder, and then we are going to go ahead and create a main.tf file. I'm going to then go ahead and just copy one of these and paste it in. All right. Always let my error message guide me. So it needs an app name. So let's go ahead and create the variables.tf file. And let's create a variable that's going to be app name. And that's going to be fine. All right. The next variable that we need is going to be this one here, because we could call it front end, but we don't want to call it front end because we don't want it to be specific to any tier. So what I'm going to say is repo, we'll just say here, and then we'll have the name be var app name dash. I think then we'll do var.tier. So what tier of our application are we going to be creating a repo for? So that works. And then this should be fine. Okay. And let's go back to our main here. And so instead of calling each resource, we can go ahead and say module ECR, source ECR, app name, var.app name, and then tier is going to be equal to front end. And then let's copy this. And then this tier is going to be equal to API. All right, and then we should be able to delete this. Perfect. So now anytime we want to create a repository, we can just use our module instead and pass in the app name or the tier and the tier. All right, so let's apply that. We're going to get a Oops. So we're naming ECR both times. So module ECR front end, and I should spell it correctly. Then module ECR API. And then we're probably going to get the Terraform init issue, which we do. Perfect. All right. And then let's look at Terraform apply. Looks like it's doing good. Let's go ahead and just take a look and make sure that our ECRs are going to be all right, ECR API, ECR front end. Perfect. All right. So we have our ECR module, our IAM module, and our VPC. Let's go ahead and move on to, all right. I see that database has some references to the private instances and the Bastion instances. So I think I'm going to hold off on RDS for now. I'm just going to try to knock off the very easiest ones first. So I think I'm going to go into the Bastion module. Which doesn't look bad. All right. So we're going to create our folder, Bastion. Let's create a main.tf in there. Let's close out of all of these other files that we don't specifically need. All right, and then let's go ahead and copy all of the resources and let's paste them in. All right, so we immediately see that we need a variable for app name. So we can go ahead and app name. All right, looks good. Everything else looks happy so far. You can see that it's saying module.vpc.vpcid, but we don't have a module in here to call. So instead, we are going to say var.vpc_id, and then we will add it here. Perfect. All right, let's keep going. This is just referencing the security group above. All right, here we are getting private subnets. So we're going to go ahead and we're going to say variable subnet ID there. And then we will go ahead and put this as var.subnet ID. That's just referencing the security group. Then here we want to call this instead. Let's just call it EC2 profile, var.ec2 profile name. Let's add this here. All right. So that actually required quite a bit of variables to make, but that's totally okay. The only one that seems that we might need to do some work on is this EC2 profile name. Let's go over here and we will call it then. So we're going to say module Bastion. And then source is going to be Bastion. All right, so app name is going to be taken from the variable app name. That's perfect. VPC ID is going to be taken from the VPC module, VPC ID. We are actually not using a public, we weren't using a public subnet. We were using a private subnet for this Bastion host. So that's good. And then it looks like we're using the profile name. Is that something that comes out? Looks like it does already. Did we do that in the last video? Let's go to outputs, EC2 profile name. EC2 profile name. Perfect. All right, so that was easier than expected, hopefully. And I'm going to go ahead and move this up just because I like my modules at the top. Oh, oops. Apparently I didn't move the ECR ones up, so we'll have to do that too. And then let's move these up as well. All right, cool. Let's go ahead and Terraform init so we can avoid getting that error message, and Terraform apply. Ooh, and we have an error. All right. So here we are having an issue in 238, which is in here, where we reference the Bastion ID. So we need some outputs in this Bastion folder. So let's create a file and we'll call it outputs.tf. And it looks like we need the security group ID. So we can say output security group ID. All right, that looks good. So now we should go back and be able to go into main, and instead of calling it by saying it's this security group, we should be able to say module.bastion.security group ID. And that will get it from the output. All right, so let's go ahead and apply that and see how we do. And it looks like it is happy to add those. All right, so just a note, just because Terraform is happy to apply doesn't mean that you won't get any errors when you do apply it. You still might get errors when you apply it. So it's not completely safe to be like, oh, well, when I hit apply, it planned it fine, or when I ran plan, it did it fine. You always want to like fully test everything that you're doing. All right, so now we have our RDS module, our load balancer module, and our EC2 module. So let's take a look at this. So it looks like we were pretty much able to just reference the Bastion module. So if we have another resource that does the private instance, we just make sure that those need to be created before the RDS, which isn't the end of the world. It's not circular. The private instances don't need anything from RDS. So RDS modules shouldn't actually be too hard. So we'll go ahead and create the RDS module. Let's do main.tf. All right, I can go ahead and close out of quite a bit of these. And then we are just going to, I'm going to open these up. But then we are going to cut all of this and paste it in here. So we already need variables.tf, so we can do a variable for, our app name. All right, so that looks good so far. All right. This is referencing the security group up here, so that's fine. So this is referencing the private security group ID. So we're going to change this to a variable. So we're going to say private security group ID. Let's add it to our list of variables. All right. Perfect. So that's just referencing security group here. This is then referencing our Bastion security group ID. So we want to go ahead and add that here as well. All right. Let's keep going. So this is referencing our private subnet IDs from the VPC module. So we need to change this to private subnet ID is going to be the variable name. And yep, that will be a list of strings and the value of the private subnet IDs. Perfect. Then we need to have a variable for DB username and DB password to be able to pass in. So let's add those. Then let's do sensitive true. And let's do the same thing for our password. All right, that looks pretty good. This is referencing our subnet group that we defined here, and this is referencing the security group that we defined there. So that should be good. So let's get rid of this. And then let's go up here and let's call, Then we're going to say source is going to be equal to ./RDS. And app name is fine. VPC ID is good. Yep, that's going to be our subnet IDs. Yep, that's going to be our, nope, we don't need a database security ID. What do we need? Sometimes Copilot is right and sometimes Copilot is wrong. All right, so we don't even need the VPC. I'm just now being silly. All right, so we need app name, private security group ID. So let's do private security group ID, which is going to be equal to AWS instance. No. AWS security group, private security group ID. Perfect. And then we, after that, need Bastion security group ID. So we're going to say Bastion security group ID is equal to module.bastion.security group ID. All right. I'm going to make a space here for readability. So app name is pretty different than the security group IDs. And then private subnet IDs would come from the module, so that makes sense. And then we need DB username and DB password. So perfect. All right, so that looks good there. So let's go ahead and Terraform init. Terraform apply and see what the issues are. All right. Reference an undeclared module. RDS main. All right, so we forgot to change this to var.vpcid. So we'll need to add it here. All right, so we did need it. All right, I'm going to add it with the subnets. So we're going to say vpcid is equal to module.vpc.vpcid. All right, now try again. And looks like it wants to create that. So perfect. That will wrap up then our RDS module. So now we have quite a few modules, but you can see that we were at 300 lines of code and now we're at 220 and we still have 2 more modules to make. All right. So we have all of our modules except our private EC2 module and our load balancer module. So let's take a deeper look into how these two use each other. So that way we can understand what we should, how we should modularize this so that it's not a circular dependency. Because for example, we do have other dependencies, right? Like the RDS depends on the Bastion host security group and the private instance security group. All right. So there are dependencies, but we just want to make sure that there's not circular dependencies. All right. So let's take a look at the private instances first. So the private instances that we have, right, we have a security group with an ingress rule where we're saying that the load balancer security group. Okay, so the load balancer can come into the API and the load balancer can come into the front end. All right, so that requires the load balancer to be created. All right, and then open all, and let's see. Okay, so that doesn't seem too bad. So it's just those security rules. So what we could do is we could leave these security rules in this file here if we wanted to do it after. Let's look at the load balancer. The load balancer gets created. Allows all HTTP traffic in and then all traffic out. We create the load balancer. All right, here is where we attach, right, our instance to the target group that we created. And then here is where we attach the front end, the instance to the front end attachment. So what I think I'm going to do is I'm going to leave these attachments outside of the module. So the way this work then is that the ALB would be created. All right. Then the private instances would be created because they depend on knowing the ID of the security group. All right. And then after both of those modules are created, then just in this main file, we'll just leave the target group attachments out, and those will get created after the private instance is done. So it'll be ALB, private instances, and then the target group attachments. All right. You could probably do this an opposite way by leaving the security group out and flipping it. You do you, experiment with what it is, as long as your application is deployed and everything works the way you want it to, it's not the end of the world. All right, so since we're not really doing anything different with the private EC2 module, let's just make that one first. All right, so we're going to do main.tf. All right, and then let's just go grab everything from the private EC2 module. And let's paste it in here and see what needs to be changed. So the first thing that stands out, like the rest of them, is going to be this app underscore name. And that is going to be type string, description, value of app name. That's fine. All right, so that's fixed. So now you can also see here, let's go ahead and get rid of some of this. So instead of VPC ID from coming from the VPC module, we will change this to var VPC underscore ID. Then let's go ahead and add this here. So we're going to have a variable VPC ID, type string, description, value of VPC ID. Perfect. All right, let's keep going. So this is using this security group here. And then here we are referencing the load balancer security group. So we could probably do like LB security group ID underscore ID. And this is going to be a variable. All right. And then this will be the same here. So we'll just copy and paste that in here. Then let's go ahead and make that. So variable load balancer security group ID string value of the load balancer security group ID. Perfect. All right, let's keep going. So this is referencing up top. So here is going to be private subnet IDs. So let's use a variable instead, and we'll say var dot private subnet IDs. All right, let's go over here and make that a variable. All right, that's a security group up here. So now it looks like we also need this var dot EC2 profile name. So we can go over here and do variable EC profile name. That's good. All right, and then I think we should move this Docker script into the folder because you can see here it's referencing the same folder. So we can go ahead and try that. All right, and then instead of here, we're going to call it module private EC2, and then source private EC2 app name, and then VPC ID. It's going to be equal to module.vpc.vpcid, and then next load balancer security group ID. That looks good. Then next, we have private subnet IDs, which is going to come from the VPC. And then next, yep, EC2 profile name. All right, that looks good. I'm going to move these around a little bit. And then space them a little bit differently. Sure. All right, that looks good so far. Let's Terraform init, and then we can press Terraform apply to see where we got. Oh, okay, so apparently it pulls it in from, so let's try that. So it didn't like me moving it in. I'm curious if because we're calling in the module here, if that is where we're at. Okay. All right, so we're doing better. No, we're not doing better. All right, here we are. All right, let me pull this up a little bit. I'm going to clear this so I can actually see what my errors are. And then, all right. So the clear did not help apparently. All right. So main 140. So it looks like we're going to need some outputs, I think is the moral of the story. All right. So main 70. All right. We're referencing the security group private security ID. So that means that in here we need some outputs. .tf, and then the first output that we are going to need is going to be security group ID, and we should be able to then replace this with module dot private ec2 dot security group ID. Perfect. So that's the first issue. Let's go to 140 and take a look at the second issue. All right, we need the instance IDs, it looks like. So let's go to output and we're going to say output instance IDs. Like that. Then that will go ahead and get the instance IDs. And then where are we? Line what? All right, so here then we will have module dot private ec2 dot instance IDs account dot index. All right, let's do the same thing. So I'm going to copy this. Then let's go to 158. So this should be the same thing. We want the instance IDs. All right, and then private ec2 main.tf line 46. Maybe here. All right, I'm just gonna recall this now because I'm confused as to where the errors are from. Oh, no errors now. All right, so that looks like that will plan everything, and we'll go ahead and click no. All right, we are on our last module, which is going to be our load balancer module. So I am going to go ahead and create a folder, and we are going to say ALB. And then within the folder, we will create our main.tf. All right, so let's first take a look at the issue. All right, so I'm going to actually just copy everything and paste it in here. All right, let's make sure we have our variables. And we're going to have a variable for app underscore name. All right, let's keep on keeping on. we are going to then need a variable for VPC ID. So let's add it in here. All right. Next, so this is referencing the security groups. That should be good. Same here, same here. All right, so here we need public subnet IDs. So we're going to do var.public subnet IDs. And let's add that variable here. Public subnet IDs. All right, perfect. Keep going through. This will be the API target group. So we need the var.vpcid here. So here is going to be our instance IDs. All right, so let's try to pretend that this works. So we'll do that. Let's make a variable for it. All right. Then this is going to be the VPC ID here. And then this here is going to be our instance IDs. All right, just trying to look for all of the potential items that are being referenced from other modules. And this looks pretty good. All right, so now let's actually call our load balancer module here. And our source will be ALB. And yeah. All right, so technically, if we were doing this module the exact same way as we were doing the other modules, we would be done and we'd be able to go. So let's go ahead and give this a try. So let's do first Terraform init. And then let's do our Terraform apply. All right. Main 88. Oh, okay. So here we're referencing the load balancer security group. So that means we need to add an outputs.tf and an output here. Let's do load balancer security group ID. Perfect. And so then this would change to module.alb.loadbalancer. All right, so you're seeing here that our private EC2 has an input from the ALB module, and that's output from that module, right? And then our ALB module is using an input from an output of our EC2s, all right? So let's go ahead and see what our next error is, if any. And interesting, it seems to say that it wants to work. So let's go ahead and give it a try and maybe it'll error later. Or maybe it will work and I'm wrong. That's fine too. All right, I'm gonna let this go for a little bit. So I'm gonna pause it and I'll resume when we either finish creating or hit enter. All right, well, lucky for us, it says that everything added. So apparently Terraform is smarter than me, which makes sense. So let's go ahead and get AWS up and let's get our GitHub Actions up and let's see if we did everything right and everything was created. All right, so we have all of our resources. Let's go take a look. Sign in. All right, so what we want to do is we want to go to EC2 because we need our instance IDs. And it looks like we have our private EC2 1, private EC2 2. All right, so let's go to our simple, I think it's like DIP is what I was using. Yeah, DIP simple API. Also a note on this, I'm using this DIP simple API repo for my filming. So the repo that I put into the link to the repo that I put into the challenges, that's the one that you should be using to pull the application code from. I have a different repo for when I'm practicing versus when I'm filming, and then versus when like the challenge is ready. So even though you see me using this one, you shouldn't use that one. I hope that makes sense, but feel free to let me know if it doesn't. All right, so let's go into EC2 1. Let's get that instance ID. Let's paste it in there. All right, let's go into instance 2. And let's paste it in there. All right, so we have our instances updated. Now we need to update our RDS host. So let's go to RDS. And let's grab this endpoint. All right. So that should be good. Everything else should be fine. So I'm going to expand my window. I'm going to go to actions here, and I am just going to rerun my last update here, all my jobs, because I haven't changed the code at all. So there's no need to like push new code because I have no code to push. All right, but this is going to go ahead and build my Docker image and then deploy to EC2. So I will go ahead and pause the video here while we are building and deploying, and then we'll take a look and see if our Terraform changes worked out or if we messed anything up. All right, see you in a sec. All right, so we have our API and our front end image built, and now we are deploying. So I'll head back over to EC2 and we can go ahead and connect to one of our instances. It looks like front end is done. Let's do a Docker ps-a. And yep, it looks like we have both of our containers up and running. So if we went to and curled localhost at port 3000, looks like we might be running. All right, now it's saying it's done. Cannot get error code 404. Oh, I think it's because it's /API. Yeah, my bad. I forgot about the /API that we added last week. So our back end is working. So let's go ahead and try to curl our front end. And the front end looks like it's working. All right. We have both have been deployed. So now let's go to our load balancer and let's take a look. I'm just going to go ahead and test adding a to-do and editing a to-do because that should show me if everything works. All right, so to-do got added. I refreshed, my to-do still there. If I mark it complete and refresh, it's still there. Let's edit a name. Let's edit a description. Refresh again, mark incomplete, refresh again. I mean, at this point it's overkill, and delete. Perfect. So it looks like we have successfully modularized our Terraform code. All right. So we are now going to create an EKS cluster. What is an EKS cluster? I guess let's start with that. All right. So let's go and let's just look up EKS. A fully managed certified Kubernetes conformant service that simplifies the process of building, securing, operating, and maintaining Kubernetes clusters. All right, so basically from this, Amazon has a Kubernetes service that simplifies using Kubernetes. Well, that's pretty exciting, right? So when you run applications on EKS, you can choose to provide the underlying compute power for your containers with EC2 instances or with AWS Fargate. So we're going to use EC2 instances as our worker nodes. All right. This is going to be kind of a difficult next few weeks because Kubernetes is a big topic. And we're going to just try to focus on as minimal information as possible to deploy a full stack application with EKS and Kubernetes. All right. But just use this as kind of your starting point. All right. Google, do some research, watch some videos, look at how you could change some things, but know that this is just the beginning. This is not going to be an extensive Kubernetes course. We could do a 10-week extensive Kubernetes course, and this is not it. All right. But what you do need to know, so let's look up Kubernetes. All right, overview. Trying to find it's like a good drawing that we can use. And I probably should have done this before I started recording. This is fine. Okay, so yes. So essentially what we are going to have is you have nodes in Kubernetes that are within your cluster. So what we're going to create now is the cluster that has our nodes inside it. And nodes are basically EC2 instances. So imagine that this is an EC2 instance, this is an EC2 instance, and so on. All right. Kubernetes we can use Docker to create pods, and within those pods, Docker containers are run. So what we'll have once we deploy our full stack application is a front-end pod and a back-end pod the front-end pod will communicate with the back-end pod. The back-end pod will communicate with RDS instance, our database. All right. And they will each, in the pods, they will have the container running in them. All right. Why would we use Kubernetes? Well, Kubernetes allows us to scale, right? So right now, when we deploy our private instances, we're specifically deploying 2 containers on our private instances. Yes, we have 2 instances, but the 2 instances are mostly just in case an availability zone goes down, right? If we needed to scale, we would need to deploy more instances and then change our GitHub actions or manually go deploy. The cool thing about Kubernetes is that Kubernetes does that for you. All right. So instead of us doing the work to be like, oh, wait, we only have 2 instances, we need 10 instances of our application up and running. Let's go create all of them. Let's change our Terraform code. Let's do this. You don't have to change your Terraform code. You don't have to go into the AWS console. All right. You just have to either set up automatic scaling or you have to just say, hey, instead of 1 pod running my API, I want 3 pods running my API. All right. And then Kubernetes does the work for you. All right. Some other benefits. If, for example, my EC2, my application doesn't deploy successfully right now in our GitHub actions, right? We'll see that it will say didn't work. All right. But what if you were actually running an application in production and you deployed a new feature and the deployment didn't work? Well, you would have just broken your deployment for all of your customers using your application. Now, when you're just deploying practice projects, you don't have any customers, so not that big of a deal. But when you're in production, you do. So what Kubernetes does for us is it allows us to roll back. It allows us to deploy a pod and then check if it's working. And then if it's working, switch over all of the rest of our pods to that one or roll back, right? With minimal or no downtime for the customer. All right, so Kubernetes can be complicated, but there are many benefits as you get bigger and bigger with scale and complexity of your applications. All right. We're going to try to do the basics, just the minimum of what you need to know. But if this is exciting to you or this is fun for you, let this be your diving ground to keep exploring. All right. So that was a pretty terrible introduction to Kubernetes, but let's go ahead and take a look at what we're going to do instead of what our current infrastructure is. So I'm going to leave our VPC because Kubernetes is just going to be just like in this picture, right? We have our Kubernetes cluster with our instances inside of it. Well, all of that's going to be inside of a VPC.
All right, so we still are going to have our VPC with public and private subnets. All right, our IAM policies. Let's go take a look at what IAM policies we have. So these are being able to use sessions manager, read ECR. All right, and this is for EC2 instances. All right, we might be able to play around with those a little bit, but for now, I'm going to leave that in because our IAM policies aren't a big issue. We'll need our Bastion host still because our EKS cluster is going to be completely private. So we won't be able to just be like, hey, cluster, please make another pod. We need to use the Bastion host to tunnel into our cluster, just like we do with our database. All right, so we're going to leave the Bastion host. We'll still need a repository to put our image for our front end and for our back end, and Docker will still need to pull from it. But instead of having our EC2 instance directly pull from it, we're going to use Kubernetes. But we still need our repositories to store our images. Ultimately, we'll still need our database, but right now, I'm actually going to comment our database out. And the reason for that is because the database takes a really long time to create, and we're not actually going to deploy an application this week. Well, we're not going to deploy an application with a database this week, so we're not going to worry about that. And we don't need to create private EC2 instances because we are going to create what's called a node group instead. As you can see, remember from that picture, right? Here's another picture. All right. As you can see, our EC2 instances are these nodes, all right? And then our pods will go in it. All right. So we don't need to create our private EC2 instances ourselves. We're going to do that by creating a node group and then just saying how many nodes we want. All right. And our ALB. We're again using a private EKS cluster. We're not going to actually make it internet facing quite yet. So we're going to comment out the ALB as well. So far we're going to have our repos, which actually we can comment out because we are not going to deploy an actual image quite yet. So I'm not going to worry about those, but we'll leave the Bastion host. I guess the IAM policy is not really necessary right now. All right, so we're going to do a VPC, our module, and our Bastion module. Let's just keep it simple so that way we're not deploying and paying for more than we need to. All right, so I'm going to go ahead and Terraform apply this. So that way I can get my VPC up and going and my Bastion host up and going without, okay, so I do need IAM in order to get my Bastion host up and going. So that is good to know. Thank you, Terraform. So this is going to create our VPC and our Bastion host and the IAM policies that are necessary for our Bastion host. All right, but we're going to actually go to the console to create the EKS cluster. All right, so we have our VPC and Bastion host up and running. So let's go ahead and create a cluster. Now, I like to always create something in the console before I move ahead to create it with Terraform, so that way I understand what is necessary in Terraform. So that's what we're going to do. Create the cluster. All right, so you're going to go to EKS, by the way, which you can just type in EKS in the search to get Elastic Kubernetes Service. All right, enter name. I'm going to do coding with Kali, EKS cluster. We can just select the version, the default version here. All right, so we need a cluster service role. Select the IAM role to allow the Kubernetes control plane, okay, to manage AWS resources on your behalf. So basically, Kubernetes works by having a control plane and then worker nodes. All right, so the control plane is kind of like the brain of Kubernetes, and the worker nodes do all of the work and have your application running on them, which the worker nodes are just EC2 instances. Okay, so Kubernetes tells those EC2 instances what to do. So what we need to create an IAM role for that Kubernetes control plane, and we to give permission and say, hey, Kubernetes control plane, you are allowed to do your thing, manage my worker nodes. Okay, so I don't have a role right now, so I'm going to go ahead and click this create a role in the console. But keep this in mind, though, that you will need to do this with Terraform, right? All right, so we are going to select a trusted entity, which is going to be an AWS service. And then we're going to select the EKS cluster as our use case. So we are allowing the EKS cluster, all right, to do something. Allow access to other AWS service resources that are required to operate clusters managed by EKS. Perfect. Next. All right, so it's going to be adding this Amazon EKS cluster policy. And this is the thing that it's allowing it to do. So it's allowing it to do auto scaling, a lot of different things with EC2, a lot of different things with elastic load balancing. All right, so we're going to go ahead and say next. We'll say role name. We can say, I don't know, EKS role. Sure. And let's create the role. Perfect. Then we can return to our cluster and hit the refresh. And you can see that now it's going to allow us to select that role. All right. I'm going to just leave cluster access at allow cluster administrative access. And I'm going to allow it to have access. The cluster will source authenticated IAM principals from both EKS access entry APIs and the AWS auth config map. I'm going to just leave it as the defaults. All right, and then I'm going to go ahead and click next. All right, I'm going to change the VPC to my coding with Kali VPC. All right, and I am going to unselect or deselect the public subnets. All right, because we don't actually our EKS cluster, we're going to make completely private. All right, and we'll have a load balancer be the one to direct traffic into our cluster down the line. But for now, we're just going to keep our cluster within the private subnets. All right, security group. It's going to just create a security group for us. So I'm going to just leave it blank. All right. And then we're going to say that we want a completely private endpoint. Now, if you're new to EKS and you want to do some more playing around and not follow this tutorial step by step, I recommend going ahead and selecting the public one just to play with. But I'm going to show you how to actually use the Bastion host to get into the private. But for my own learning, it was helpful to make my endpoint accessible publicly until I figured all of this out. I'm going to kind of give you the secret, but if you want to back up a few steps and like make sure kind of you can play around with this without following this word for word, go ahead and create a separate thing in your own time. I guess all of this is your own time, but that's public. But for this course, make sure you do the private one. And if you ever are in production. All right, so this is going to be like your metrics and logging. I'm going to not turn any of on because I'm not going to worry about that right now, but you would likely want to do that in a production setting. All right, I'm going to leave the default add-ons and click next. All right, then I'm going to configure selected add-ons and settings. I'm just leaving them all as default. And then now we're going to review and create our cluster. So that seems good. And I'm going to go ahead and create. Woohoo. So an EKS cluster, just like an RDS instance, takes a really long time to create. So what I'm going to do in the meantime is I am going to start creating my IAM policies for my nodes. Okay. So let's go ahead and I'm actually going to go look at my bookmarks for this. So I actually found this really great step-by-step guide about Terraform because I had a very difficult time figuring out all of the permissions to add to the IAM role from my node, my worker nodes. but I found this for the Terraform, which is super helpful for the Terraform of the EKS, which we'll do later, but it's also super helpful to know about the IAM role that we need for the node group. Okay? So if you look, they're creating a role that is essentially going to be for the EC2 service. It's going to give permissions to the EC2 instances. All right. And it's going to allow the EC2 instances it's going to attach to it the policy, the Amazon EKS worker node policy, the Amazon EKS CNI policy, and the Amazon EC2 container registry read only policy. So let's go ahead and look those up and kind of get an understanding of what we're saying that these EC2 nodes are able to do. All right. So this policy allows Amazon EKS worker nodes, which is just EC2 instances, all right, to connect to Amazon EKS clusters. All right, that makes sense. The worker nodes are going to be part of your EKS cluster, so they would need to be able to connect. All right. Let's look up this one. All right. This policy provides the Amazon VPC CNI plugin the permissions it requires to modify the IP address configuration on your EKS worker nodes. This permission set allows the CNI to list, describe, and modify Elastic Network interfaces on your behalf. All right. So these are all of the things that the policy is allowing the EC2 instances to do. All right, so that's going to help us with networking. And then let's look up this one. Provides read-only access to Amazon EC2 container registry repositories. All right, so basically this allows us to read our repositories on ECR. All right, the only one that I'm still a little bit foggy on is the CNI policy. So let's go ahead and read more about this. Okay, so the EKS docs say that before you create your worker nodes, you have to create a role with these policies. Oh, this is why you do it in a separate role. Yeah, I'll actually bookmark this. It's an interesting read. I'm not really going to worry too much about it, but I'll include it. Maybe this one gives us a better. Okay, EKS implements cluster networking through the Amazon VPC container network interface. Okay, so this is how our containers are going to communicate to each other. It allows Kubernetes pods to have the same IP address as they do on the VPC network. More specifically, all containers inside of a pod share a network namespace and they can communicate with each other using local ports. All right, so the VPC container network interface is going to allow the pods to communicate to each other. So that's going to allow our front end pod to communicate to our back end pod. All right. When an instance is created, EC2 creates and attaches a primary ENI, Elastic Network Interface, associated with the primary subnet. The primary subnet may be public or private. Ours is private. The pods that run in the host network mode use the primary IP address assigned to the node primary ENI and share the same network namespace as the host. The CNI manages the ENI on the node. Sorry, now I'm just reading in my head. All right. So then now let's go back and read this. provides the CNI plugin the permissions it requires to modify. So this allows the CNI to do its thing on the worker nodes. Okay? All right, that makes sense to me. So let's go ahead and create that role. Let's check in on our cluster and see how we're doing. Looks like we're still creating. All right, so we're gonna do AWS service, and then this is gonna apply to EC2. Allows EC2 instances to call AWS on your behalf. Let's just make sure. Yep. All right. Then let's do next. And then let's look for each of these things. So let's do EKS worker node policy. EKS worker node policy, add that. Next one, the EKS CNI policy. Add that. And then container. And then let's do EC2 container read only. All right. So let's do next. All right, so we have our 3 policies. Let's call it EKS node role. And then create role. All right, so we have our EKS role, our EKS node role. Perfect. All right, that is still loading. So I'm going to go ahead and pause here, and I will come back when this has been created. All right, so we have an active cluster now. All right, so then if you go and look at compute, that's going to tell you what resources you have to actually run applications in. Excuse me, EKS cluster, it is running. Please try again in a few minutes. It says active here. I'm going to not worry about it. All right, but you can see that we have no nodes. All right, so we have to go ahead and add a node group. So we can click on this button for add node group and then type in our name, coding with Callie node group. And then let's select the IAM role, and you can see that we have EKS node role. All right, which we just made. Let's go ahead and click next. And then we're just going to leave the default as is. So our instance type, so each of our nodes is going to be a T3 medium, which is probably way too big, but we're going to delete this right after. And then we can say what size we want our node group to be. So we can say what the desired size of node should be, the minimum and the maximum. And that's going to be how much it can scale and to and from. All right. So I'm going to leave it at the default just because we're just setting it up. All right. And then maximum that can be unavailable at one time, which would be just one. All right. Next, we're going to go ahead and use our private subnets for this. Click next. And I'm not going to add any labels or taints. Taints would be like kind of like rules restricting what can go on a certain node. And leave those as default, and then I'm going to click create. All right, so this is once again something that takes a little while, so I'll refresh. I'm going to go ahead and pause, and I will return when my node group is hopefully up and running. All right, so now we have a node group with 2 nodes in it. And you'll notice that these nodes, if I go to EC2, are just 2 EC2 instances. All right, and I have my Bastion host. All right, we officially have an EKS cluster. And with that, we have a node group with 2 nodes. Those nodes are just EC2 instances. All right. Now we actually want to deploy our applications to this EKS cluster. But how do we do that? We are going to use the Kubernetes command line tool. All right. So similar to how you use Docker's command line tool to build and pull and push and run and list all of your containers, do all of the things that you need to do with Docker. You use kubectl to do the same thing with Kubernetes. All right. Under the hood, kubectl is going to know what cluster to communicate with through the .cube/config file on your computer. Okay. So what you all are going to do is you're going to install kubectl. All right. I used Homebrew for macOS. And once you get it all installed, then you can start updating your kubeconfig file. Now, how do we do that with AWS? How does kubectl know that we have an AWS cluster, and how do we connect to it? Well, you can go ahead and use this handy dandy command here, all right, to connect. And what this is doing is it's saying, hey, AWS, can you get the EKS cluster information and then update my kubeconfig? All right. Then you're going to say, well, my cluster is in US East 1, so that's where you should look for my cluster. And then my cluster name is CWC EKS cluster. And you click enter. All right, and then it's automatically going to update our context in our .cube/config file, so that way it knows that, hey, we're working with the Coding with Callie EKS cluster. All right, let's take a look. So you can go sudo nano.cube/config. You'll type in your password. And now we see that we have our cluster and our context. Also our user. All right. Now, this is the most important line here. So when I type in kubectl, what is happening is that this endpoint is getting pinged. All right. Kubectl is going to be doing any command that we type with kubectl. So let's say we say kubectl get nodes. All right. That's the command that you use to get the nodes in your cluster. So those would be our two EC2 instances. It would list those out. All right. But how does it do that? Well, it has this cluster endpoint, right? And that's what it communicates with to get the resources within that cluster. All right. So where does this endpoint come from? The endpoint comes from over here. Go to overview. You'll see the server endpoint here. That's the endpoint that we hit in order to interact with our cluster. All right. So now that we have kubectl and we've updated our kubeconfig, let's try to use kubectl and say kubectl get nodes. All right. Make your guesses now if it's gonna work. So it's not gonna work because nothing is ever easy in this world. So why doesn't it work though? That's the most important thing. It doesn't work because when I type in kubectl, it's hitting that endpoint. But my cluster is private, all right? I don't want anyone who's able to access my AWS account to automatically be able to edit my cluster and everything in it, okay? It's just an extra level of security that your cluster is private. So you can see that we have a timeout. It tried hitting this endpoint, right? But there was a timeout, all right? Because it's private, it's never going to work. So what do we need to do instead? Now, this part is kind of confusing. It is kind of, at least in my opinion, it's hard to wrap my mind around, and I have to kind of review it over and over. So if you don't get why this is working the first time, that's okay. Rewatch this video, do some research. All right. But what we're going to do is we are going to use our tunnel again. So let's go and take a look at that. So we're going to be working on localhost over here. All right. And we're going to make up a port, some port. Sure. Let's say it's 1053. When we hit localhost at 1053, we want that to tunnel through our Bastion host and into our EKS cluster. Okay. So we're going to set up this port forwarding. All right. When we did our database, we were actually able to set connect to pgadmin at localhost at that port. So that step was kind of done for us. Here, we have to do some of the work. We have to do that redirecting, okay? We have to say, hey, when kubectl is used and it tries to hit this endpoint, I don't want it to actually try to hit that endpoint. I want it to hit localhost, okay? And that is what we're going to do first. First step in this is just say, hey, computer, If I try to hit this endpoint, you're going to hit localhost instead. All right, so let's set that part up first. All right, so the way we're going to do that is we're going to change our etc hosts file. So I bookmarked a page about this, okay, redirecting a domain to another domain locally. The most important thing to note is that you need, okay, so we need a IP address, which 127.0.0.1 is the IP address for whatever computer you're working on, okay? So that's your local computer. All right, so what you're saying here is if I try to hit either one of these sites, I want you to redirect that traffic to 127.0.0.1, which is my local computer, okay? So when we write it here, I'm going to say sudo nano. I can just open up the etc host file. All right. You can see that here we have localhost being configured. If I use the word localhost, I want it to hit 127.0.01. All right. So I'm going to say 127.0.0.1. I'm also going to write localhost here just because this is how I always do it. But now that I read more about it, it feels like I probably don't need to include localhost there. And then I'm going to go and grab my endpoint minus the HTTPS. Okay. Just that end part. All right. So what I'm saying here is if I hit localhost or I hit this, I use my kubectl command, which is trying to hit this endpoint, I want that traffic to be redirected to my local computer. All right. So now we have that part of the puzzle down. All right. Let's go ahead and try kubectl, get nodes again, and see what happens. All right. You can see that it pretty immediately said no thank you to us. And we're also getting this like it was refused because we're not doing the forwarding of the traffic quite yet. Okay. So we have two more pieces to this puzzle. The first is using the port forwarding, right? We actually want to say like, all right, I'm going to design a port on my local computer, and then I want that to forward to the thing. So what are we trying to do? We're trying to, when I use kubectl, we're going to add a port onto that endpoint. So actually, let's do that first. All right, so I'm going to say sudo nano.kube/config. All right. Remember how I said this server line is the most important? Well, it is, okay? Here's what we're doing. We are going to add a port on here, okay? So we are going to say something like 3443. Okay, I always add a 3 before the like actual port number. So EKS is HTTPS, so it's 443 is the port number. So I just add a 3 onto it, 3443. Okay, so this is configuring kubectl. So I'm saying when I use kubectl, all right, I want you to send the request to this address at this port. All right. My computer then is like, ding, 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 ding. We have this address. What we really mean here is localhost. Okay. So then it's going to convert this to localhost, and then it's going to send the request to localhost at port 3443. Okay. Let's see what happens when we try this now. All right. Still nothing because it's saying, hey, I tried to hit this address at this port and nothing happened. Are you using the right port? Right? Because we got the final piece of the puzzle, which will be really funny if it doesn't work. The final piece of the puzzle is using this SSM command, right? This is the same command that we used. Gee, dang it. All right, there we go. All right, this is the same command we used to forward traffic to RDS. We're doing the same idea, but we're using EKS instead. So I'm going to go ahead and delete everything. So this was 3443. That's the local port number. The port number for EKS is 443 because it's HTTPS. We need to go get our Bastion host ID. Here's our Bastion host. Copy that instance ID, and we will paste it in there. All right, and then now we need to go get our EKS host endpoint minus the HTTPS, okay? So let's go back to our EKS cluster. And copy all that minus the HTTPS. And let's get forwarding. All right, so now it's waiting for connections. It's opened up this port 3433. So let's go ahead and create a new tab here. And we can go ahead and say kubectl get nodes. All right, and what's happening when I say kubectl get nodes? It is going behind the scenes. It is looking up that server line. No! 3443. Is that what we used over here? 3443. All right. I actually hear my dog barking upstairs, so I'm going to pause real quick and I'll be right back and then we'll debug. All right. Let's debug. So first I'm going to look up EKS port. All right. Yep. 443. All right. I'm going to go ahead and look at this again. Oh, I know what I did. Okay. So we ended up getting a timeout. Why did we get a timeout? So when we created our EKS cluster, and I've done this 3 times now. When we created our EKS cluster, we went ahead and let's look at it. We let it create its own security group, okay? This is also another benefit of Terraform because then you don't forget to do these random little things. So this is going to be our inbound rules. So we're allowing, let's go and look it up. I'm trying to figure out what this security group is. All right. So we are allowing all traffic within the cluster is basically what this is saying. So that's the automated security group that it's set up for us. But we're not allowing traffic from our Bastion host. So we need to do that. So we need to add on port 443. We want to allow our Bastion host to talk to it by using the Bastion host security group. Let's save our rules. All right, and see, this is, again, the great part of Terraform is that I just have to remember to set this up once, and then I don't have to be like, oh, wait, I forgot a random security rule. All right, let's go ahead and kubectl get nodes, and that came back quickly, so yay. Things that you would see to make sure this worked. First, you'll automatically see a connection accepted. All right, so that's good. And then the next thing, obviously, you'll quickly see your nodes. All right, so we said kubectl get nodes, and we got both of our EC2 instances back, which are our nodes. And both the statuses saying that they're ready. All right, so this is how you would access your EKS cluster using kubectl. All right, so now that we have kubectl working, right, we can say kubectl get nodes. And here are our nodes. Quick note, you will have to have this command running in order to connect. As soon as I disconnect here, I'm no longer running the tunnel. If I try kubectl get nodes, it's gonna not like us, okay? So make sure that your tunnel to the port forwarding to remote host is going. Then you should be able to enter commands. All right, so we have 2 nodes, 2 EC2 instances. I feel like we worked really hard, so now we should have some fun with Kubernetes, okay? So the first thing that we're going to explore with Kubernetes is a pod, all right? So let's go look at the documentation. Pods are the smallest deployable units of computing that you can create and manage in Kubernetes. A pod is a group of 1 or more containers with shared storage and network resources. So most of the time, pods are used in 2 main ways. A pod that runs a single container, All right, this is the most common use case. So container would be your Docker container, right? And then the pod would kind of manage that container, make sure it's continuing to run. Okay. If something's wrong with container and there's an error and it stops, the pod will restart because Kubernetes is an orchestrator. So its whole goal is to do what it's told. If you're telling it, run this pod, it's going to run the pod. And if the pod fails, it's going to restart it and keep trying. Okay. The next option is that you would have multiple containers in it. We're not really going to do anything with multiple containers for this workshop, but you could have like a sidecar with logging or something like that in it. Okay. So there's kind of a few different ways to make pods. The first is with a YAML file. All right, so this is a simple YAML file. Basically, you say what kind of resource you want to use, you name it, and then you say what container image you're going to run and what port and stuff like that. Okay. The other way that you can use pods is just with the command line interface. So I could, instead of writing out this YAML file, what I could do is I could say kubectl run. And then I'm going to, so run is the command that you would use to like run a pod. And then you would name it. So if I say NGINX Pod would be the name, then I can use the flag dash dash image, all right, and then say NGINX, all right. And then this is kind of like the simplest command that you could use to get NGINX Pod up and running. If I want to go look at my pods, I can say kubectl get pods. And now you can see that I have one pod, all right. Now, what's this ready column? 1 out of 1 refers to the amount of containers within the pod. There's one container in the pod and it is ready. Okay. If we had a container in the pod that wasn't ready, it would say 0 out of 1. That would be if the container's erroring or something. Status then is that it is running, and then restarts is at 0. So like I said before, Kubernetes just wants to follow directions. So you're saying, hey, run this pod. All right. If something happens and it crashes, it's going to restart and then you're going to see a counter there. Typically, if something's restarting over and over, it's because there's an issue with your container or your code or something. So that's typically a sign that, like, hey, something's going on with your pod. You should go check it out. All right. You can also use the command add onto it -o wide. Okay. And that will give you a lot more information about your pod, including the IP address of your pod. So you may ask, could I just say curl and then curl the IP address? And if your guess was no, you can't do that, then you are correct. All right. And why can't you? Well, you can't because it's a private cluster. So the only way for you to hit that pod and get a response is if you're making that request from within the cluster. Okay. Now, are we eventually going to get to a point where I'm going to show you how to access an application running in a cluster from the internet? Yes, but that is going to be in the next few weeks. We're just going to focus on the smallest unit right now, which is a pod. So you can see this curl command, it's just not going to work. So we're going to close out of it. All right. But what if I want to see that NGINX homepage really badly? Well, let's make it work. We know that we can get to a pod and access, like communicate with a pod from within the network. So what if we make another pod and then make the request from there? Let's do that. All right. So we are going to make a temporary pod. So we're going to say kubectl run, and then I'm going to call this temp pod. All right. Because I'm only starting this pod up simply to get inside that pod and then make a request to the actual application that I'm running. Okay. Then I can go ahead and say -- image. We can just use NGINX because we can make a curl request from NGINX. All right. And then I'm going to say -- rm. If you remember that command from Docker, that is going to remove this pod after it stops, after I stop using it, right? So then I also need to say -it, which is going to be saying I want to interact with this pod. I actually want to get inside this pod. All right. And then I'm going to say -- and then sh. And that's going to say that I want to be able to use shell when I'm inside of it. All right. So it says if you don't see a command prompt, press enter, and that just gets me. So now I'm inside my pod, right? All right. So now what I want to do is I want to go ahead and curl that IP address. And now you can see that when I ping that pod, right, from another pod, and they're both in the same cluster, that then I see my NGINX homepage. So that's pretty cool. But that doesn't fully kind of tackle what we're doing here, right? Why are we using Kubernetes? We're using Kubernetes because we want to be able to scale, right? So I am not, most often you would never, like, not, I don't know if I would say you would never, but like you typically aren't going to use a pod's IP address. And why is that? Because typically you're scaling. And so you're going to have you could have thousands of pods. You're not going to ping each IP address of the pod. And then also the whole point of Kubernetes is that it's going to recreate pods, right? If they go down for any reason, because it's trying to maintain like the end goal. So what happens if I have this pod and something happens, it goes down, Kubernetes creates a new one, well, it's going to have a new IP address. So you're never really going to use the IP address, okay? What are you going to use then? You are going to use something called a service to expose your pod for networking, and we are going to go over that in a minute. All right, so this diagram is a little bit more complicated than what we're going to do right now, but I just kind of want to expose the idea to you of what the service is for. Okay, so let's say we have this is called a replica set. Basically, you create a deployment, and then in your deployment, you say, I want 3 pods that do this. Okay, and that creates a replica set under the hood. Anywho, you know. So let's say we have 3 replicas of our application. And we scale because we just have so much traffic that we just want to make sure that we have enough applications running so that way our super popular application never goes down. Okay? So it's going to have 3. Each of these applications are going to have their own IP address. So it doesn't make sense, like we said in the last video, to be like, oh, let's ping this one, then this one, then this one, right? We're not going to do that, especially because what if like this one goes down? Kubernetes is awesome because it's going to spin another one up for us, but it'll have a different IP address. So instead, what we do is we create a service, okay? And we basically link through the use of a label and a selector, but we'll go over that later. Don't worry about it. But we basically say this service, all right, exposes these pods, okay? And then it handles it all for us, okay? So instead of pinging and communicating with the pods directly, we communicate with the service. And we say, hey, app A service, can you please send this request to app A? And the service does it with magic, okay? So we are going to create a service, and what we're going to use is we're going to use the command line interface, and we are going to use this expose term here, okay? So we're going to say kubectl expose, and then what you can do is you can use -- help to get some handy dandy examples of what we want to do, and then also just the different options. Okay, so I want to expose my pod. So this one, right, creates a service for a pod, valid pod, which serves on port 444 with the name front end. Okay. This example exposes container port 8443. All right, we don't need all of this, but basically what we're going to do is kubectl expose, then what we're exposing. So we're exposing a pod, the name of the pod that we're exposing, which ours will be NGINX Pod, the port, and then the name that we're naming the service. Okay. We also are going to use the name or number for the port we're going to use target port, the container that the service should direct the traffic to. Okay, so let's give this a try. So we're going to say kubectl expose pod NGINX pod. Okay, then we're going to say -- port is going to be port 80, then -- target port. So port is going to be the port that the service is running on, and then target port is going to be the port that is being targeted on the container inside the pod, right, is going to be 80. And then we're going to say dash dash name, and we'll call it NGINX service. Oh, and apparently I hit service. We already have that running because 15 minutes ago I practiced. So let's do kubectl delete service NGINX service. We want to do everything. All right, then let's rerun this command, and we have our service. I've confused myself a lot. Service / NGINX service exposed. So let's actually go back and do kubectl get service, and that way we can see what we have, and we have NGINX service here. Another handy command that you can use is the describe. So we can say kubectl describe service NGINX service, and we'll get a lot more information about it. Okay, so you can see, right, when we used expose, it went ahead and edited and created the label for the service and the selector. The selector is saying how do we connect this service to the pod, right? We can't use IP addresses because those can change. So we're going to select based on a label in the pod. So let's take a look at that label in the pod. So we're going to say kubectl describe pod, NGINX pod. All right, and here's all the information about our NGINX pod. Okay, so if we go, let's look. Should I feel like it? Oh, see labels. No. Okay, yeah. See labels run is equal to NGINX pod. That automatically get created when we use the run command, right? And then you can see that the selector for our service is run NGINX pod. So it's saying, hey, I'm going to connect to any pod that has the label run equals NGINX pod. Okay. So what does this do for us? What does this service do for us? Well, it allows us to connect to our pods without the IP address. So let's go all the way back. Am I being lazy? Yes. Let's go all the way back to creating our temp pod, okay? So I don't remember what the IP address of my original pod is. So even if I wanted to curl it, I wouldn't know what to do, right? But what I can do is I can say curl nginx service at port 80, and I can get my HTML page for Nginx, okay? So this is kind of under the hood if you don't, what is happening on a small, simple scale, right? So we are going to create a pod essentially for our backend, okay? Then we're going to create a backend service that will, we only have to talk to the backend service, and the backend service does the networking for us, okay? And then the same thing, we'll create a pod for our front end and so on. All right. But we don't want to just create a pod. We want to create a deployment. All right. So deploying a pod was pretty fun. And honestly, for personal projects, you might just use a pod, right? You might not need to ever scale up or scale down. But deploying a deployment doesn't really have like a downside to it, okay? Because what you're doing basically is you're saying, hey, I want a deployment. All right. In my deployment, I want 3 replicas. And then I'm going to give you a little template of what each of those replicas should look like. Okay. So, like, it's not super complicated. You're saying, I want 3 containers that are running the Nginx image. All right. So, this is a simple YAML file showing you how to do a deployment, right? And as you can see, deployment is just creating a replica set under the hood. Okay. You can also use the command line interface to do it as well, which I haven't done this in a while, so let's see if we can do it. So we're going to use kubectl create, and then we can say deployment, and then I'm going to use -- help. All right. So we are creating a deployment, we're naming it, and then we're saying the image, and then we're saying how many replicas. So this actually looks pretty, close to what I want. So we're creating deployment, we'll say nginx deployment, and then we'll use -- image nginx, and then -- replicas 3. All right, and then let's clear. So let's go ahead and do kubectl get pods. And now you can see that we have this pod that we created 18 minutes ago, and then we have 3 pods that all fall underneath the NGINX deployment. Okay, so let's delete that original pod. So kubectl delete pod NGINX pod. All right. One of the first things that you can do that's cool is if you created each pod individually. Let's say you were like, ooh, I need my API. I'm going to create a pod. And they go, ooh, I would like another pod. This isn't too hard. Let me just create another pod manually. Well, when you delete, you have to go through and delete each one. But right now, I could, and I'm not going to follow through on this, but I could say delete deployment, NGINX deployment, and it would delete all 3 of my pods for me, which is pretty cool. All right, so you could also do kubectl get deployment, and you can see that we have an NGINX deployment. We have 3 pods out of 3. 3 are up to date, 3 are available. All right, so now let's expose our deployment. So we're going to say kubectl expose deployment -- help. And let's take a look. All right, so it looks like it's just the same expose command. Looks like they have a nice one here. So let's clear my terminal and paste that in. I'm going to just keep it simple with keeping the target port and the port the same. We're going to expose deployment NGINX dash deployment because that's what it's called. And then let's name this service that will be created. So we're going to say dash name NGINX. I'm going to name it NGINX service like that. I think it's upset because of I don't have a space. There we go. So if we do kubectl get service, also SVC is the shortcut for service. I'm trying to type everything out long, but technically you don't have to. So let's do kubectl delete service NGINX service because we don't need that anymore and we don't have the pod that it's corresponding to. All right, so now if we get the service, you can see that we just have the one there. All right, let's back all the way up and get our temp pod up and running. Okay, first, what I want to do is I'm going to do kubectl get pods -o wide, because first we're going to do the old-fashioned way and we're going to get the IP address. Okay, so you can see we have these 3 IP addresses. So then let's do let's get our temp pod. All right. And then let's say curl, and then we'll hit that. All right, perfect. We hit our NGINX image. That's awesome. All right, so now let's see if we can hit our NGINX service at port 80. Oh, that worked too. All right, so that's awesome. All right, but what happens if we want to scale down and we no longer want all of these pods? Let's see if we can scale down. So we would do kubectl, I think scale -- help. All right, so maybe I can do, so let's try kubectl scale deployment NGINX deployment -- replicas 1. All right, so it scaled that for me. So now if we go back and look at kubectl get pods -o wide, you can see now that we only have 1 left, right? And if we look, it's not the same pod. I mean, it would have been funny if it would have been the same pod, but it scaled down, so it got rid of 2 of them. So this IP address that I copied before is gone. So if I go and let's say I had an application running that had an Axios request to that endpoint, that IP address, you can see it's not going to work because I scaled down my resources. You don't want your application to break when you scale down your resources. You want to be able to scale up or down. You want to be able to have pods come in and out and not worry about like, oh crap, I broke this. But you can see that if I curl nginx -svc at port 80, you can see that that still works. All right, so there's several things that we created manually in the console. So we're going to go through and kind of delete them together so that way you don't get a charge. The first thing that you need to delete is your node group. Okay, so you're going to go ahead over to the compute tab, go to the node group, select it, and then we're going to click the delete button. All right, then you just need to type in the name and of the node group, and that way you can delete. All right, that is going to take a little bit. So while that's deleting, I'm going to go to my IAM because if you remember, we created 2 IAM roles manually. So I'm going to highlight those 2 roles here, and then I'm going to delete. All right, and I can go ahead and click delete there. All right, if I refresh, you're going to see that those roles have been deleted. All right. So then we also have a security group. I'm pretty sure when I delete my cluster, the security group will delete with it. But just to be safe, I'm going to go ahead and go to here and click delete security group. Oh, 6 network interfaces. So we can't. But I'm going to delete my inbound rule that I added for my Bastion host just in case it sees that and it gets mad. You probably don't have to, but just let's leave this open so that way we can come back and make sure that that got deleted. All right. So while this is deleting, we can also go ahead and delete our Terraform. So we're going to go ahead and Terraform destroy because remember we made up our VPC and IAM and Bastion. So we'll go ahead and destroy that. Yes. All right, I kind of forgot I was filming here, so I'm going to go ahead and press pause and wait until the rest of the things delete. Did that delete? Oh, still deleting. All right, I will pause and then come back, but basically we just need to delete our cluster after. All right, so hopefully that's deleted now. Yep, we have no node group. All right, so now we can delete our cluster. So we're just going to take the name, copy it, paste it, and delete. And that should take a little while, but when it is done, so yep, we have deleting here. When it's done, we should be all set. All right, so I'm going to pause it again, and then I'll come back and take a look to make sure that the cluster is gone and the security group is gone. Let's check the, oh, we're still getting rid of our subnets, but we're probably still getting rid of our subnets because the EKS cluster is in our subnets. So we'll check on both of these things in a minute. So maybe finish destroying your cluster and your node group before you move over to your Terraform. All right, so it looks like our Terraform resources have been successfully deployed or destroyed. I don't know what's wrong with my brain. It's too late. And our cluster is gone. All right, let's go and just quickly check. And yep, our security groups that we created are gone too. All right, so we will end this video here, but just to summarize what we did, we created an EKS cluster manually this week. We figured out how to use kubectl and create and destroy and edit resources within our EKS cluster. And we made our first pod, our first service. We made deployment. We made a deployment with multiple replicas of a pod, and then we scaled those replicas down and we made a service to expose that deployment. So we did a lot this week. Feel free to go back, study more, read more into Kubernetes. It's like just the tip of the iceberg, but it's a really fun iceberg to learn about. All right, I'll see you next week.